Hello, this is Professor Hester, and I'm continuing our discussion of CCNA networking. In this video, we're continuing our look at the physical layer. This is part 2, where we will be studying fiber optic cabling. Fiber optic cables are used in high-speed networking. They're used in the backbone of networks, where we need to send large amounts of data long distances. Fiber optics works by sending light pulses through thin strands of glass. These light pulses can be created through laser or LEDs. And fiber optics has higher bandwidth and can be used at longer distances than copper cabling. One nice thing about fiber optics, it's immune to interference, such as EMI, that we were concerned about with copper cabling. And you can see in the lower right-hand corner, I have an example of a multi-mode fiber optic cable from Monoprice. This cable is aqua, and while it's made of glass, you can see that it can be bent to a certain degree without damaging it. There's two primary types of fiber optic cable. The first type is called single mode fiber, or SMF. SMF fiber works by sending a single beam of light through the fiber. It has the highest bandwidths and the longest distances. So this fiber is optimal for the internet backbone, where we're sending massive amounts of data around the country or between continents. It has the least optical loss, so it's very efficient, and usually this cable is yellow. The other type of fiber optic cable is called multi-mode fiber, or MMF, and this is the more common type of fiber optic cable that you'll see. This is used inside of buildings or between buildings on a campus, and it works by sending multiple beams of light through the same cable. These beams bounce off the walls of the cable so that multiple beams can be sent simultaneously. Because we have multiple beams, multi-mode fiber will be 5 to 6 times larger than single-mode fiber to accommodate the larger core. It's cheaper than single-mode fiber, so that's why it's primarily chosen for campus backbones or within a corporate facility. And usually MMF is aqua or orange. Now let's talk about fiber connectors. Most cables only support sending data one direction, so you'll find with fiber optic cables they're usually bundled in pairs. The connector on the end of the cable in the picture binds the two cables together and plugs in as a single unit, although this multi-mode fiber actually has two different cables, one for each direction. Fiber optic cable, because of the glass and other characteristics, is more difficult to terminate than copper, so it takes more skill to install. Now let's look at something called a submarine cable map. And this is an interesting website where you can see how fiber optic cables have been installed around the globe. This picture was screenshotted from early August in 2024. I'm going to pause here and I'm going to bring up this website live so we can see what it looks like at this moment. All right, this is a current view of the submarine cable map. You can see how in some areas we have far more density of cables, such as, I'm going to zoom in here a little bit, between the eastern coast of the United States and Western Europe, there are quite a few cables that have been run. Likewise, from the west coast of the United States, there are quite a few cables that are running between the United States and Asia. If you hover over a particular cable, you can see information on it or find information by selecting them on the right-hand side. It's interesting also to see where there's certain parts of the world where there's a lot of cable density, while in other areas where there's not as much technology that's been installed, such as in the southern part of South America, there are far fewer cables. So I think it's something that's kind of interesting to play around with and see how these have been installed. Next, let's look at small form factor pluggable transceivers, which can be abbreviated SFP. And these are little transceivers that we can put in a port and a switch. So the switch I have shown you here on this screen is a Cisco Catalyst C1000 switch. And most of the ports on this switch are gigabit ports, but the 4 ports over to the right are actually slots for these SFPs. And this gives this switch flexibility because I can buy different types of transceivers depending on what I want to install in the switch. The transceivers on the upper right-hand side are a fiber optic transceiver. And you can see in the picture, if you look carefully at it, how we have the 2 holes for the fiber optic cable for each side, the sending and the receiving 2 cables. So I can take this fiber optic transceiver, I can plug it into the slot in this switch, and then I can plug my fiber optic cable, and now I have a fiber optic port. That's useful for if I want to have a high-speed, high-capacity uplink to another area of my network. Or if I wanted to install additional Ethernet ports, I could get the transceiver at the bottom of the page, which is an Ethernet gigabit speed transceiver. I can put that into that slot, and then I can plug in my Ethernet cable as I would normally do so. And each of these transceivers is relatively inexpensive, so this is an easy way for me to make my switch adaptable and modify it as my network needs change. So now that we've talked about fiber optics and we've talked about copper, let's compare the 2 types of media. I've created this chart for you here with a list of features and how they apply to both copper and fiber optic. First, we have bandwidth. Copper is generally going to be 1 gigabit per second, sometimes 10, and in extreme Cat8, for example, we might get up to 40 gigabits per second. But fiber optic is going to be far more reliable for that, more readily available, and with fiber optics we may be getting up to 100 gigabits per second. Of course, as technology changes and things are developed, these numbers could be modified. With distance, fiber optic also outperforms copper. Copper is going to be limited to 100 meters due to attenuation. Your signal will drop off, while fiber optic cables can go 100 kilometers. And likewise, in interference, copper has issues with EMI and crosstalk, but fiber optic cabling is completely immune. So why would we not always choose fiber if it's best with bandwidth, distance, and interference? Well, copper is going to outperform fiber optic with cost and installation skills. Copper is still the cheapest media to use, and it's far simpler to install.